Hi guys, we are back for another demonstration. I'm going to put this about the center of the board here. Let me just scoot that back a little bit, okay? And we're going to give a quick demonstration of this. Alright, so let me slide this a little bit over here. So for you guys, if you're looking, yeah, so it's going to be a little longer lecture on here, so let's slide over here, okay? So anyways, I'm going to just to briefly talk about the hexagon, and I want to show you some of the properties here of this hexagon. So now this is a six-sided figure, and it has six sides. So hex means six. Hex means six. And then we have some formulas that are provided to calculate this. This is, by the way, a regular hexagon. So we call this a regular hexagon. Six-sided, right? Six sides. Okay? So we have a regular hexagon. This is a screw. Rubber application is designed of a screw or nuts. It's going to be used to tighten up materials like wood. So let's say you have a frame. You want to put a frame, okay? And we're going to make these pluses so you can screw in the frame, right? This is your frame. So you're going to put in the frame or whatever inside the electronic component or even by electronic component, okay? So this idea is used for is to tighten up the force, right? So when you do that, you tighten up the force of something, right? And that's what it's doing, and use a Phillips screwdriver to do that, to accomplish that. So that's going to go into a medium, which is a wall. So I'm going to draw a wall here. So it's going to go through the wall, right? So like that. So I'll put a little dot for that. So it's going to go through the wall to hold this panel together. And the wall consists of certain materials. Okay, draw that. Like certain materials to help bond this together, right? So the atoms got allowed for this to go through and to bond them together. So you have this atom right here, which strengthens the bond of the material, right? So this adds more impact on the pack of atoms, right? So that's what we do this. And then the physics is so a little bit complicated. So yeah, you see a lot of activities going on here. So this is a little small demonstration of how this works. So I'm going to show you guys that. This is a bonus lecture we're doing. I thought I'd give you a grander tour of a real-world application of geometry. So let me go ahead and raise this up a little bit and show you guys what I'm talking about. So yes, this is like a grandy tour of our applied geometry here. And it's really cool, guys. It's really awesome. All right. So this is definitely going in our video section. And you might be wondering if you're into engineering or construction, you might find this idea very feasible. So what do you guys think? So if you're on my YouTube, please subscribe. If you're on TikTok, you know what to do. I can't use that word. So anyway, yeah. This is awesome, guys. And what else is used for? It's used in carpentry too. You might have to nail in some stuff or staple some stuff, right? Same idea, guys. So I think this is bonus lecture. It's very important. And if you're working with bolts, nuts, you know, they are regular. So this principle definitely is feasible for that. This gives you the background material, how a bolt really works. And when it comes to design, guys, like the design aspect of this right here. All right, guys, thank you for watching, and I hope to see you next video. Let's give you guys one more run of this. All right, guys, bye-bye.